So we're doing some more simplifying roots. Just a couple of special cases we want to look at today. Most of them involving what happens if you have a root with parentheses. So if we look at our first one here, this is actually one of our big special cases here. So the square root of 2x plus 1 to the 6th power. So let's start off with the math part, and then we'll get into what makes this one a little bit trickier. So if you're dealing with roots and you have a set of parentheses, keep in mind you're not going to mess with what's in the parentheses. So whatever you start with is going to be part of your answer. So I know I'm going to have 2x plus 1. That's not going away. Okay? So the only thing I really want to look at is what is my index and what is my power under the radical. And then we simplify that the same way we did yesterday. So we could think of it as just division. So 6 divided by 2 is 3. So this is going to become 2x plus 1 to the 3rd power. Okay? And that's almost our answer. So the special condition here is we have to, oops, let's undo that. Maybe let's leave it at 2. And just erase it this way. Okay. So when you're dealing with square roots or any even root, what's under the radical can't be negative because you can't take the square root of a negative number. That's imaginary, right? But if I look here, I've got 2x plus 1 to the 3rd power. I can put whatever I want for x here, and I'll be okay. I can raise that to the 3rd power. But since it's to the 3rd power, this could very potentially equal a negative number. And that's also impossible going back to my original. So if we're looking to simplify it, we need to make sure that this will only accept numbers that will still be true for the original equation. So we need to keep this answer from being negative. And we have tools for that. You got to think back, what can I put that'll always make my answer positive? And you'd be like, oh yeah, those fancy looking, those bars, right? So for our answer, we say it's the absolute value of 2x plus 1 to the 3rd power. Okay? Now you don't always need that. The only time this is going to be true is if you have an even index and a negative power in your solution. Okay? So both of those things are true. If you start with an even index, 2, 4, 6, 8, whatever, and you end up with a negative power at the end, you've got to put absolute value signs. It's the only time. Okay? Like if we look at our second example, it's the 3rd root, cube root, negative y minus 9 to the 9th power. As soon as I see, okay, this is odd, I have an odd index, I don't worry about absolute value. I just answer this like I would any other problem. Okay? If we did this, if we changed the problem, if we said this was the square root of, let's say 2x plus 1 to the 8th power, right? So I'll put my 2 out here. If I divide 8 by 2, I would get 2x plus 1 to the 4th power. So I have a positive solution here. So no matter what I put for x, this is always going to come out positive, which means it's okay. I don't really have to worry about absolute value. And then this is my whole solution. So the only time you need absolute value, even index, negative exponent at the end. Okay? So let's look at some other variations of this problem. What if I had the same problem, so square root, but let's say I have a coefficient here, so 2x plus 1 to the 6. We go back to the original problem. Okay? So I can take the square root of 4, that's just 2. And then I have my 2x plus 1 to the 3rd power. okay? If we're looking to simplify this as much as possible, because we do need the absolute value sign, right? That's the same as the original case here. If we want to simplify this as much as we can, we only put the absolute value around the part that could potentially be negative. So you're not going to put it around this 2 on the outside. It would still just go around my parentheses and the exponent next to it, okay? So if you're taking the root and, oops, and you have a coefficient, that's always going to stay outside of your absolute value, okay? You're not going to have to worry about that. But you are going to see that on your answer choices. And like mathematically, like if you graph this compared to, if I write it out, 2 times 2x plus 1, I'm almost positive graphically you would get the same thing. But in terms of simplifying as much as possible, we want to take whatever we can out of the absolute value. So this is the answer you would want to pick, okay? All right, what else, what else, what else? Another variation. What if we get rid of the parentheses? What if we said, I don't want to write this. Let's say the 4th root of x to the 8th y to the 4th. Yeah, that's a good one. This will give us a couple of different situations altogether. So we have an even index. So you got to keep in our mind, maybe we need absolute value sign here. 8 divided by 4 is 2, so this would be x squared. 4 divided by 4 is 1, so we'd have y, just y, okay? So we said it needs an even index and a negative power. So if I look at x squared, that's even, that's good. If I just see y, you might think, oh, well, that's fine too. I don't see an odd power there. But if you consider it, if you don't have an exponent written, we know that's to the 1st power, right? And then that is an odd power. So if we wanted to write this answer, we would have to put x squared. This is not my best bar here. X squared, and then y with the absolute value sign, okay? So if you have multiple variables, any variables you have left over with a negative power, you need to make sure you put the absolute value sign, okay? And again, that's only if you started out with an even index. If this was a 5 and this was 10 and 5, right? We would still have the same answer down here, but we would no longer need the absolute value because we started off with an odd index, okay? So definitely make sure you have this rule. You're thinking about that as you're answering your questions. Okay. Actually, one more. We got one more kind of problem you're going to see. What if we have negative or square roots, negative, just say -4. Why not? Don't even worry about anything else. So, and this is just a reminder, this is nothing new, that you can't take the square root of a negative number, but we can factor this out and say this is the square root of -1 times the square root of +4. And then we can take the square root of -1. It's just not a number, it's just I. And the square root of 4 is 2. So the square root of -4 we say is 2I. Or you might see it as I times 2. Okay? So anytime you're trying to take the square root, if you have an even index and a negative coefficient, you know you can get rid of the negative sign by just putting I in your answer and then solving the rest of the problem like you normally would. Okay? Again, if this was an odd index, you don't worry about I, you just solve, like this one here. So the cube root of -1, right? We don't see a number here, but we know that's a 1. So that's just going to be -1. And then y minus 9 to the 9th power. So 9 divided by 3 is 3. So this is just going to be y minus 9 to the third power. Okay, again, remember, whatever's in the parentheses is going to stay in the parentheses. Leave it alone. You simplify your roots, so 9 divided by 3 is 3. I don't have to worry about absolute value since I started with an odd index. And I can simplify this a little bit more by not writing the -1, just putting y minus 9 to the third power. Okay, so it's not too tricky today. There's just a whole lot of little rules that you need to remember about how roots and exponents work, especially when you start dealing with negative values. So good luck on that. Take your time. Write down this one rule. Should be fine. Okay, bye.